All right, everyone. Let's go and get started. Thank you for coming out to hear my talk for your last session of the conference. Hope you've really enjoyed all the amazing talks we've had here. So I'm really excited to share on this. I think it's going to hopefully build upon maybe some of the ES6 talks that you've seen here at the conference. So this one's called ES7 and Beyond. So basic gist of this talk is we're going to look at a few of the features that are coming down the pipeline in ES7 and later versions. Some really cool features that you can already use now, and we're even seeing some popular libraries advocating for their use. So we're going to look at that and then quickly look through sort of the process that TC39 uses for developing these features. And TC39, that's the group that's responsible for the ECMA 262 ECMAScript standard. So let's get started. I'm Jeremy Fairbank. I'm a web developer. I'm on GitHub as jfairbank, Twitter, El Papapollo, and I blog at blogjeremyfairbank.com. So if you're interested in how you can reach me there. I work for a company called Push Agency, so I'm mainly a front-end developer, a lot of React stuff these days. And so we're a design development agency, and we're all completely remote, so I get to work from home, which is really awesome. In addition to that, we have our own product called Simply Built, and it's a website builder, website management, domain management as well, and it's perfect for small, medium businesses, personal use. So check it out if you're interested. So we're here to talk about ES7. JavaScript's been really evolving over the past few years, if you've noticed. ECMAScript 6 was just fully standardized this year, and we're already seeing tons of new things coming down the pipeline. So I'm pretty excited about that. Now, you've probably also heard terms like this, ES 2016, which they've tried to move toward this formal year format. Maybe you've heard of ES.next, or maybe even ES.later. And at some point, I was saying, okay, ES, what is going on here? Because I'm really confused. And so I wanted to dive in and figure out what's going on, because I was kind of shrugging, what's up with all this terminology? So as it turns out, a lot of these proposed features we're seeing, they're not necessarily coming immediately in ES7. Some of them might come after. So that's why there's this distinction between ES7 and ES later. So that kind of made me sad, because I'm excited about some of this cool stuff. But thankfully, we have awesome transpilers like Babel that allow us to utilize these features today. So if you've not heard of transpiler, the basic gist is we're going to take code from one language and transpile it down to JavaScript code, specifically ES5 compliant code. In this case, we're talking about taking ES6, ES7, ES later code, and we're going to make it into the equivalent ES5 code. And obviously, I mentioned Babel. It's a really awesome transpiler. It's grew in tons of popularity over the past year. So Sebastian and the rest of the team have done amazing work with it. So I mentioned TC39. That's the group that's responsible for developing the ECMAScript standard. And they have this 5-stage process for developing these proposals. And we're going to walk through each of them very quickly. So the first stage is stage 0, called the straw man. And this is really informal ideas, just basic ideas about syntax and features and what it could do. And so it's nothing set in stone. It's very experimental, and you got to be highly cautious using these features. So a couple examples are the function bind operator and do expressions. The next stage is called the proposal stage, stage 1. And at this point, the champion for the feature has made some good use cases for it, and they've even developed a high-level API for it, possibly. And one we're going to dive into further here is the class and property decorators. Next stage, stage 2, that's the draft stage. And at this point, the champions kind of fleshed out some specific syntax and semantics, so we have an official spec document that's been written up. And another great example that we'll see later on is the object and the rest and spread operators for objects. Stage 3, this is the candidate stage. So the proposals went through the ringer. It's went through several of the stages already. So we've completed the spec, and right now it just needs some further review for any final refinements. And there's quite a few at this stage. One is the SIMD, single instruction multiple data. And you've probably heard of that before from like systems programming, but it's a way where you can work with multiple numbers at the same time with one instruction. There's the exponentiation operator like Python and Ruby, a helper method on arrays called includes, which just checks if a value is in an array. And then the big one, which I'm most excited about, and we're going to look at further, are async functions, which provide us a way to treat what looks like synchronous code, but it's actually asynchronous, and so it's really powerful. And then finally, stage 4, it's just finished. At this point, it's been through the full vetting process, and we know we want to include this, so it's just ready to be included in the next version of JavaScript or ECMAScript. And right now, according to their documents, it doesn't seem like there's any proposal at this stage at the moment. So I want to go ahead and throw this out there, just word of warning. These are all future features. Nothing's been standardized yet. The further along you get in the stage proposal process, they are more stable, and you can feel comfortable using them. But I just want to warn you, if you're going to try these features out in production code, be wary that if they decide to drop any of these, then Babel is probably going to drop it, and then you're going to have to refactor your code. So try it out in some pet projects or maybe some unit tests. Give them a shot, because it's definitely important that you try these out so you can give useful feedback to the group that's working on ECMAScript. So we're going to start off with stage 1. We're not going to really get any of the stage 0 stuff since it is so highly experimental. So I mentioned class decorators. And these are really powerful constructs. So you've probably seen them before in some other languages. This idea of annotating your class or your methods on your class, a way to modify them. So what we're going to have in this particular example is we're going to have an @ sign, and we're going to have some identifier that will evaluate to a function. And we'll use that as a way to annotate our ES6 classes and their properties. So I want to start off to give a reason why you might want to use this and what are the benefits of actually using these decorators. So I have this ES6 class. It's a person class. It takes a first name and a last name. Then it has a getter for full name, which is just the concatenation of first name and last name. So I'm going to instantiate this person and say I want to loop over the properties of the person. I'm going to enumerate them with a for in loop. I'm going to get back first name, I'm going to get back last name, but notice I don't get back full name, and I wanted that to be included in the keys that I enumerated. So what's the problem here? Well, with ES6 classes, when you define these getters, in the background, what's transpiled, it's going to utilize object.defineProperty to add these properties to your class, but that enumerable property is going to be set to false, so you can't enumerate it. So if this is something you desire, then you would have to think about, okay, what's a solution to this? Well, one approach is break apart the person class. So now it just has the constructor. And instead, we're going to expose the fact that this is really a prototype we're working with. And so we're going to call define property on it to add the full name getter. So we can explicitly say, I want this to be enumerable. And that's normally the way we could fix this. So now we instantiate the person, we enumerate the keys, and we get back full name. But this is a little problematic. It introduced some complexity, and it's less declarative. So we've had to step outside of this class abstraction. We've had to expose the fact that we're using the prototype, and we're going to have to set something on the prototype. I won't get into the pros or cons of using classes. I know there's a lot of debate over those in JavaScript. But if you're going to use this abstraction, it would be nice if you could stay within the bounds of that, not have to step out of it and work with the prototype. So here's how we can do it now with class decorators. So we're going to return to the original person class, but now we're going to do something different with the getter. And it's deceptively simple. We're just going to tag it with this @enumerable annotation. And so that's all we've done, is we've just preceded it with @enumerable. Nothing new, just one extra line of code. And now, if we go down and instantiate the person and we enumerate the keys, we will in fact get back full name, the getter, in addition to the first name and last name properties. So really cool, very declarative. But how does that actually work? Seems really magical, not something definitely really new that we've never seen in JavaScript before. So it's, in fact, really simple. It's just a function. In fact, it's just a few lines to define this enumerable decorator. So a decorator is just a function, takes 3 parameters, target, name, and descriptor. And what you want to accomplish is you want to somehow modify this class, the property on this class, and so you want to work with the descriptor. So we'll walk through all these parameters. So target, that's what actually is being modified. If I'm inside a class, I'm modifying, or I'm annotating a property, then what I'm modifying is the prototype. So target would be your prototype, the person prototype in this example. Name will be the name of the property that we're adding. So that was the full name getter. And then descriptor, this is an object literal. And so remember I mentioned in the background, your getter is getting defined by a defined property. So really what we're doing is we're hooking into that process, and we're getting the opportunity to change this object literal called descriptor that gets passed to object defined property. So that gives us an opportunity then to either mutate it or even return a new descriptor. So that's what we're doing here. Remember, enumerable is by default set to false. So in this case, we can just modify it and say, I want enumerable set to true. Now that means this return descriptor is optional, but there's two approaches you can take. You can mutate the descriptor, return nothing, or you can return a completely new descriptor. And that's all there is really to defining your decorator. And if we looked at what this kind of process is kind of transpiled, when we tag that full name with enumerable, what you start off with is you have your original default descriptor. We have the getter, we have enumerable set to false, and we just have this other option configurable set to true. Next, before defined property gets called, we're going to reassign descriptor. And it's going to call your enumerable decorator, passing in the prototype, that's the target, the full name key, which was the name of the property, and then that descriptor, that default descriptor that it's created ahead of time. And notice we're using a Boolean OR there. So if we just modify it, mutate the descriptor, and don't return anything, then it'll just keep using what it already had, but it's been mutated now. Or if something is returned, in this case a new descriptor, then it would just use that. And now it's going to actually call define property on the person prototype with this new or mutated descriptor. And that's how you can hook in and do this in a very declarative manner. Now decorators, they can also take arguments, and this is where we see a lot more power come out of them. So let's refine our person class a little. We're just going to have a name, and it's going to have a greet method, which just logs out, hello, my name is Jeremy. And I'm going to tag it now with this alias decorator, but notice I'm invoking it like a function, and I'm passing in this alias. See, I have Ruby envy, and so I want 50 aliases for the same method. So I'm going to instantiate my person, and now I can call person.greet and person.sayHello, and I get the same method. So there's nothing really special here, in fact. When I invoke alias like a function, that's because it is a function. And all it needs to make sure it does is it returns a function. Remember, this just has to evaluate eventually to a function which will be used as the final decorator. So if we dive into alias, here's what I mean. We take an alias name, that's the only parameter. And notice now we're returning a new function that takes the target, the name, and the descriptor. And then inside all we do is instead of returning a new descriptor or modifying the current descriptor, we're just going to add a new property with defined property. And the basic gist of it is going to basically delegate. So the details of what alias is actually doing isn't as important as the fact is we can parameterize our decorators. And all we have to make sure is they return a function. Now what about decorated classes? I mentioned that briefly earlier. So far we've only looked at modifying properties on classes. But we can in fact do this on classes as well. And probably the most quintessential example I've seen so far is for creating a mix-in library, or a mix-in decorator. So in this case I have a dog class. He has a name, an age, and the dog can have a birthday. And so I want my dog, when he has a birthday, I want to emit an event that says, hey, I've had my birthday. Well, normally we would need to, if this was a class, we would want to create inheritance. We would want to, inherit from the event emitter. But that doesn't make sense. Dog is really not a specialization on event emitter. So it'd be better if we could just mix in those methods like this. And in fact, if I wanted to add a walk method to my dog, and I know dogs are quadrupedal, it's not really a specialization on a quadruped, but I want to share that code. So this way I can avoid using inheritance to share code, and instead I could use decorators to make mix-ins. So this is really powerful. And the only difference from what we saw earlier and now is we're putting the decorator before our class. So that means the function for that will just take in our dog class. And we won't really dive into the details of this mix-in decorator, but at the end I'll share a link where you can see a ton of code examples for other decorators that I've written if you want to check those out. And just to show you how we are able to grab some of the other things based on this mix-in, if I have the on callback where I pass in an event and the callback I want to react to, then that comes from the event emitter because we mixed it in. Same thing with calling this walk method. So that gives you a nice high-level overview of decorators and what's possible with them and why you might want to think about using them. Because we've already seen this being advocated by Angular 2, and if you've looked at React Redux, connecting your provider to your React components, they've been showing this in a way with decorators. So why class decorators? It's definitely very powerful, expressive, and declarative syntax. We saw we can use them to create mix-ins for classes. And then some other great examples of some decorators are like auto-binding methods, deprecating methods, memoizing, setting it read-only, and a lot more. And there's a link to, for Jay Phillips, he has implemented a ton of some of these decorators that you can use now. So that sums up what I like about stage 1. Now we're going to dive into stage 2 and look at one of the features in it. So this is object rest and spread. And this is very similar. If you've been to any of the ES6 talks this week, they might have touched on using this ellipsis operator with arrays as a way to do slicing or concatenation. So you can destructure arrays. You can grab, say, slice out everything but the first, or you can spread out values into an array. Well, now with ES7, we can do something very similar with objects. So the rest operation, where you're wanting to kind of destructure or pull things out of an object, we can use that as kind of like a pick or clone functions, something like you would see in Lodash. Now the spread operation, that's extremely powerful, and I really like that use case a lot more because it's kind of like syntactical sugar for object.assign. So let's start off by looking at the destructuring, the rest operation. Now pulling in a couple helper functions here, is equal for checking if two objects are equal to each other, and then an assert, which I'm using the function bind operator. I didn't have enough time to really go into that in depth, but it's this double colon operator, and it allows me to auto bind the assert function to console. So really what I'm doing here related to object rest and spread, I'm creating an object. It has A, B, and C, D properties. And then I'm doing destructuring on that object. And what I'm doing is I'm pulling out A, and that's going to be equal to 42. I'm pulling out B, so that's creating a B variable that's equal to the string foo. And then I'm doing this rest operation with the ellipsis, and I'm putting it on a variable called rest. And what that's basically saying is anything that I have not explicitly pulled out from destructuring yet, stuff the rest of that in this rest variable. So on the bottom there, you see my assertion that I'm saying rest is equal to whatever's left. So I pulled out A, I pulled out B. That means all that's left then would be C, which is 5, and D, which is equal to bar. So that's the destructuring side of this, and it's pretty powerful, but I've found more use cases and more power out of the opposite, which is the spread operation. So with the spread operation, what we were doing before with rest is we were pulling things out, whatever's left. With spread, we're going to do the opposite, and we're going to stuff things into an object. So in this case, I have an original object with x equal to 42, y equal to 100. And then I'm creating two new objects. One, I'm setting z equal to 5, and then I'm doing, again, see the ellipsis? I'm calling that operator on the original object. And that means take all of its own enumerable properties and spread them out in new object. Same thing with other object. I'm spreading it out, and then I'm assigning x equal to 13. But notice the subtle difference between these two. The first one, I'm doing the spread after I've assigned z equal to 5. Whereas the next one, I'm spreading it out first, and then I'm setting x equal to 13. So there are important ramifications of this. In that first one, obviously, my new object has z equal to 5, and I've spread out object, which means I pulled out x being equal to 42 and y being equal to 100. That's fine. But notice this other one. I spread out object first, and then I set x equal to 13. And then notice the new object I've created, it has x equal to 13, not 42, which was in the original object. So I'm overriding what I originally spread out. And we'll see use cases for why that's a really powerful abstraction. So just to give you, I mentioned earlier this was syntactic sugar for object assign, just so you can see kind of how this would transpile. That first one where I set z equal to 5 and then I spread out object, it's as if I'd called object assign on an object with z set to 5, and then for the second argument I passed in object. So this is like if you've not seen object assign, if you've used lodash or underscore, it's just like the extend or assign function, where it's just combining all these object properties into one. And the second one, where I spread it out first, and I set x equal to 13, it's like calling object assign first on an empty object, then passing in the original object, and then finally passing in an object with x equal to 13. And this is really important. You can't call object assign on the original object, because it will mutate its first argument. And we do not want to mutate this original object. We want to make sure we produce a new object. So when this gets transpiled, it's going to make sure it passes in an original object first. So now let's look at a couple good use cases for the spread operation. So I have this function, create dog, takes in options, and then it has some defaults. So my default dog, the breed's going to be a Sheltie, the name's going to be Tucker. And then when I actually create the dog, I'm going to return a new object. And the first thing I'm going to do is I'm going to spread out the defaults. So at that point, what I've done is I've just created a clone of my defaults. Then I'm going to spread out the options. So if you supplied any options for breed or name, those will override what the defaults were. So this is a great way to write succinct syntax for using defaults with your objects. Similarly, if you wanted to just use a cheap clone operation, you could see how you could just pass or spread out one object in a new object to basically clone it. So if I call create dog without any options, then it'll use the defaults. The breed's Sheltie, the name's Tucker. If I pass in both breed and name, then it'll use those properties. And then I can do a mix and match. So the last example, I'll just pass in the name. So what I'll get back is I'll get the default breed, but I'll get the new name of Chance. So object rest or spread operation is really powerful for doing this kind of default options that you see in functions. Another example, if you're big into React or Redux, I've seen them advocating this syntax some in your Redux reducers. So if you're not familiar with Redux, basically the concept is you have a single store which contains your application state. And whenever you want to change that state, you don't mutate it. You dispatch an action from within your application. And basically your store is going to call these reducer functions. And based on what type of action was dispatched, it's going to produce new state. So how object spread becomes powerful in this instance is your function, your reducer, it gets whatever the current state is as the first parameter, and then the action, what was dispatched. So we can use this spread operation with our current state to spread it out in whatever new state we're producing. So we at least have whatever the current state or the previous state was. And then after that, we can add whatever properties, whatever has changed in our new state. So again, this is really powerful to use. If you've really dived into React or Redux, I would cautiously advise trying to use this out in your reducers. I think it makes it really succinct and terse. So that covers object rest and spread. We've seen it's a very succinct syntax, allows us to not have to make very verbose, explicit calls to object assign. We can use the destructuring in the rest operation as well, which we could use kind of like a pick and omit, but I would still advise probably just using lodash's functions for that. We also saw we can actually clone objects. So you just create a new object and spread out the original object to clone it. But be cautious, this is not a deep clone. So any nested properties that are objects, those won't get spread out. You'll get references to the original object. So you have to be very careful in your clone objects. You could end up mutating state from your original object if it was a nested object or an array, for example. And we saw some examples how we could write functions with overridable default options, like the create dog function. So that will end stage 2 for us. Now we're going to dive into stage 3, which I think has one of the coolest features, and I hope you'll really enjoy it as much as I do. So here's my terrible pun, the moment that you've been awaiting. Async functions. So there's a lot of good reasons why I like async functions. Probably the killer thing is we gain back a lot of clarity. We can write asynchronous code that just looks deceptively like synchronous code. And that's really powerful. So the basic gist of these async functions, you're going to prepend the function with this async identifier. It's not a literal keyword like we might think of for or if. and that was mainly for backwards compatibility reasons. Now, when you declare these functions async, you can use the await operator identifier. I'm not sure the exact word. It's not necessarily a keyword either, I believe. But you use that in front of a promise. And what that basically will do is it's going to await the resolution of that promise. And so whenever the promise resolves with a certain value, await's going to take that value out of the resolve, take the resolve value out, and that'll be what's returned by this await operation. So you can assign that to a variable. So I want to start off with the motivation for why async functions are powerful and why you might want to consider them. So does anyone remember seeing code like this several years ago in JavaScript? We have some sort of asynchronous code. In this case, I want to fetch the customer name for a particular order. So I take an order ID and then a callback called done if I successfully get the customer name, and then a fail callback if there was an error. So then inside that, I call this fetch order function, which is asynchronous, passing in the order ID and another callback. And that callback is one of the error first callbacks where the first parameter, it's an error, and if it's supplied, we know there was an error. And the second one's the order that we tried to fetch. So we check the error, we log it, we then call the fail callback with it. If there was an error, then we can proceed with calling this fetch customer function. And we pass in the customer ID. And we pass another callback in, which takes an error and a customer. We check the error there, and if that failed, then we'll call fail callback. If not, we can finally call done with the customer name. So we can probably all agree this is really frustrating, really unreadable, and it's hard to reason about. So thankfully, we made progress with promises. And now we can take this sort of nested callback hierarchy, kind of flatten it out. So now our callbacks are more linear in a sense with these then callbacks. So now my fetch order, I pass in an order ID. That returns a promise. So I call then, and that will eventually get supplied the order. And from there, I can produce a new promise with fetch customer, and that will allow us to provide another callback where we get the customer, and then finally we can return the customer name. And then, of course, we want to do error handling, so we attach the catch callback in case there was an error, so we can log that and rethrow it. But in some instances, I still feel like, even as a functional programmer and someone that really likes promises, that it can be hard to reason about promises, too. So what we've done with callbacks and promises, it's still kind of workarounds for dealing with this asynchronous code. And also notice, how did we handle errors in these? We had callbacks that took error objects. In the callback one, we had to check if the error existed. In the promise one, it at least was a little more like a try-catch block. But it would be nice if we could go back to using things like try-catch when we really need to do error handling. And so that's what we gain with async functions. So now we can rewrite this function in a very stepwise imperative manner, where it becomes a lot clearer what our intent is, and we can reason about the flow of our code. So we have our order, we have our customer, but now we've prepended this function with async, and I can await fetching that order, stuff it into an order variable. And then later on, I can await fetching the customer because I've now received my order back. And then eventually, if my customer comes back, I can return the name. And of course, with these await operations, I can wrap them in try-catch blocks like it was normal synchronous code. So if internally these promises for fetch order, fetch customer, if they did a reject, or even if they threw an error, we would catch that. So this is really powerful. We can catch asynchronous code with try-catch blocks now, and then log it, and then rethrow it. So probably one of the big things, like I mentioned, asynchronous code with synchronous-like syntax. That's really powerful. So let's dive a little more into asynchronous functions and learn about kind of what they're doing and some of the ramifications of them. So we're going to go to a simpler example. In this case, I just want to print the order out. So I'm going to fetch the order and then log it. So the first thing, like I've said, we're going to prepend it with this async identifier. So we've declaring this function is asynchronous. By doing that, then, we can use this await operator inside it. And it's important we always declare the function as async, because if you try to use await in a normal function, it'll throw a syntax error. So we're going to await a promise. We're going to obtain whatever the resolved, the fulfilled value is. We'll retrieve it, and then we're able to store it in that order variable. And I want you to think, when I keep saying this is like synchronous code, imagine that we just marked out async and await, and our function looked like this. And so it was a synchronous function. And that's why I say we can write synchronous looking code that is actually asynchronous. Now, if this was synchronous code, though, that fetch order would probably be blocking. And that's a big no-no in JavaScript, because it's single-threaded, we'd block the main thread, and our UI would freeze up. The beautiful thing about asynchronous functions, it's non-blocking. Even though it looks like it would be blocking, it's not. So we're going to end up utilizing the event loop, even though we're writing code that looks like it's synchronous. So how do these work at a high level? And I say high level because if you go and you write an asynchronous function in Babel's REPL to see what the transpiled code is, it's going to utilize something called the regenerator runtime, and it's going to rewrite your code in a while loop. So it's going to look a little mangled. So I want to approach this just at kind of high level. How can we reason about how our code is getting rewritten when we mark it as async? So we got our print order function, and we're going to walk through execution of it to see how it might be turned into something that's asynchronous looking. So first, obviously, we'll invoke the function. Once we're inside the function, we're going to encounter that await operator, and that's going to trigger it to do something. It's going to say, I want to wrap whatever's being awaited, I want to wrap it in a promise. And I'm going to wrap it in a call to promise.resolve. So now we're going to transform a little into this. Now we want to use promise.resolve because as of right now, it looks like you can await non-promises. So I could await a number like 42, and that's the number, that's not a promise. But you can turn 42 into a promise by calling promise.resolve on it. Well, same thing, you can call promise.resolve on a promise. And the basic gist of what happens is that inner promise that you're wrapping, when it resolves, that bubbles up to this new promise we create with promise.resolve. So that's just the important distinction here. We always, whatever's getting awaited, imagine it's getting wrapped in promise.resolve. And so we're going to stuff that now in a promise variable. Well, now we don't want to block. This needs to be asynchronous. So what do we need to do with the rest of the code in the function? So we're basically going to come down, and whatever remains in this function, imagine as if we took it and we're going to wrap it in a then callback that gets attached to that promise. So now we're going to transform this function, and it's going to look something like this. So now we have returning promise.then, and it'll get the order parameter once it's finally resolved. And then inside it, there's our original code where we're logging it out. And so this is, at a high level, how we're able to make transpile something synchronous into something asynchronous. And then finally, we'll return a promise from this. In your asynchronous functions, if you return an explicit value, that value will get wrapped in a promise with promise.resolve again. Because we want to keep the same type that's returned from these functions. So whether you return a promise or you return a literal, it'll always get called with promise.resolve. In this case, we didn't return anything, so we're just going to use the implicit return value, which is undefined. And so that, I hope, kind of makes you better understand what is happening with these asynchronous functions and how we can make them asynchronous even though they look synchronous. And I encourage you, if you're really interested, to go to the Babel REPL, type in an asynchronous function, and see what it gets really transpiled into with the regenerator runtime. OK, error handling. We've already touched on this, and I just want to go through another example where we just kind of map error handling in an asynchronous function with the equivalent promise implementation. So now with our print order, we're just going to wrap it in a try-catch block. And then on the bottom there, we have the equivalent promise code. So let's just take this line by line and see how this easily maps to promise code. So first off, in our try block, we're going to issue the fetch order request, and we're going to await it. And then down in the promise code, it's like we just literally called fetch order, because it's going to issue a request and return a promise. Next step, in the try block, if there was no error thrown and it was a successfully returned object, then we'll have it there and we can log out the order. Similarly, in the promise, it's as if the then callback was called with the order, and we can log it out that way. If there was an error, then obviously that's going to call the catch portion of our try-catch block to run, and then we can log out the error there. And similarly, in the promise code, it maps really well. We have the catch function callback, which gets the error sent to it. So that's error handling. Just want to make sure we map it pretty well so you're getting a good picture of how the try-catch block works with these. The last example I want to look at, because this was kind of a gotcha, and I actually ran into this first when I was kind of naively thinking about how to deal with multiple requests and awaiting multiple requests. So what do I mean by sequential? So let's take an example where now we want to print out just multiple orders. So instead of taking an order ID, we'll take an array of order IDs. And we basically just want to fetch all the orders and then log them out. So one naive approach we might take is to create an orders array to hold each order, and then we'll loop over each awaited request, because now, just like we can use try-catch blocks, we can use for loops over these asynchronous calls in async functions. So we're going to await each order. Once we get it, we'll push it into the array, and then finally we can log the orders out. But do you notice the problem here? We're having to wait each step of the loop. And more than likely, there's no dependency amongst these orders. So if I fetch one order, the next order doesn't really require that I have had fetched that first order. So really, it would be nice if we could just fetch these all at once, because we don't have any explicit dependency among the orders. So it'd be, like I said, it'd be nice if we could do this in a parallel fashion. So we could rewrite it in this way. So now what we're doing is instead we're taking our order IDs, we're mapping them to an array of requests. So we just call order IDs.map, and the ID is being mapped to a call to fetch order, which returns a promise. So now we have an array of promises. If you're familiar with ES6 promises, there's this promise.all function we can call, and that takes an array of promises. And it's kind of like a barrier if you think to some of your synchronization algorithms. So it waits for all of the promises in the array to resolve, and once they resolve, then this top-level promise from promise.all resolves as well. So then we can capitalize on that. Since promise.all returns a promise that resolves when all the others resolve, then we can just await the promise created from promise.all. So we can still fetch all of our orders, but now in a parallel fashion, and we can still maintain the order, because promise.all will return, if you attach the then callback to it, it'll get an array of parameters that contain your orders in the order you provided. So basically what I'm saying is the orders array you get out of this will have the order with order ID 1 in the first slot, order with order ID 2 in the next slot, and so on. Now, the reason why I stress this so much to think about this sequential versus parallel problem is I want to show you in a demo what could happen. So basically what I have here is I'm going to issue those same order requests. I have a server in the back end that is going to artificially just set the response time for these orders. So let's first run the sequential example. So we're waiting an awfully long time here. OK, so let's look at what happens. So we issue the first order, issues pretty quickly, and then it takes around a second to respond. Notice what happens with the second order, though. On its wait time, it had to wait a whole second before we could issue that request. That's because the first order, it was waiting on that first order to respond. And then it has an awfully long response time, so it takes around 6 seconds. Now we get to the third order. Notice the wait time on it. The first order took 1 second to respond. The second order took 6 seconds to respond, so that's 1 plus 6. 7 seconds that the third order had to wait before the issue could even be sent out. The request could be sent out. And then its response time was 2 seconds. So that means we spend a total of 1 plus 6 plus 2 seconds. That's 9 seconds to get through this particular section of our code. Now what happens if we do this in a parallel fashion? We're waiting, and there we go. So notice right offhand, all three orders pretty much had no wait time. We issued them all at the same time. And then we have pretty similar response times here, 1 second, 2 seconds, 6 seconds. But notice the total running time for this section of code now. It's very tied to whatever order took the longest to respond. And that's a lot quicker than in the sequential example. It took 9 seconds. Remember, in the sequential example, your total runtime depends on the response time of each request, versus parallel only depends on whatever the slowest request was. Now, if you added on more requests, that might change a little, even in the parallel example. But hopefully, with your APIs, you're not having to issue so many requests at once. But I just wanted to make sure I highlighted this as a an important gotcha that you need to think about if you want to try out these async functions, to make sure to identify, do you need sequential or do you just need parallel? So the moral is, don't use these sequential waits unless you really need the serialization. Remember our first earliest example where we were fetching a customer name for an order. In that example, we did need serialization. The customer depended on us having first retrieved the order. So make sure when you're looking at your code, trying this out, you identify, do I need this to be serialized or can I do this in parallel? It's really important. So why asynchronous functions? I know I've been harping on this a lot, but I think it's a really important thing to think about. We can write asynchronous functions that look deceptively like synchronous code. It's really powerful. Then we gain back use of these natural or native language flow control structures. We can do a for of loop, we can do a try catch block, and we're using it on asynchronous stuff. And something else I didn't really touch on, but if you're familiar with generators and coroutines, we could utilize this in doing some asynchronous coroutine type code, which could be really powerful as well. So that finalizes looking at some specific features, some of the stuff that I've seen out in the wild in code, and stuff I've actually been using as well. Mainly in some unit test stuff, especially the asynchronous functions. They're really powerful for writing asynchronous unit tests. I do want to quickly, just at a high level, cover some of the other upcoming features. In stage 3, I already mentioned single instruction, multiple data, exponentiation operator, and the array prototype includes. Stage 2 has another function called object observe. It allows you to observe any changes that happen on your function. Think like your backbone models where you had explicitly called get and set. Well, now you can kind of observe changes to an object just through normal assignment operations. Stage 1 has a slew of features like typed objects, class property initializers, shared memory and atomics, which sounds really awesome, where you can share memory amongst web workers, and then the observable class. And then finally, stage 0, there's a couple pretty cool ones I like, function bind operator and do expressions. And then here's some links, just some extra resources if you're interested in this. First link, that's the GitHub repo for ECMA 262, and it has all these features, what stages they're at, and who the person that's championing them is. Of course, Babel. And if you're interested in going full-blown ES7 and want to try out whatever it supports, you can use this stage option and give it stage 0. And that'll enable every ES7 feature that Babel supports. There's also a link to the process document, which details all the stages and how each feature goes through from stage 0 all the way to stage 4. ES Discuss, that's their archives of discussions that when they discuss all these features as a group, as well as meeting notes and a way you can subscribe to the newsletter or the user group. And then finally, that last link from ECMA International, if you're interested in getting involved, you can actually register as an external contributor. So if you register, then you can help propose stage 0 proposals. And with that, thank you very much. Hope you enjoyed it. There's some links for code and slides there, and I think we have a couple minutes for a couple questions if anyone has any. 1 minute, so maybe one question. Yes? Oh, go back to the example? I'm not sure I understand. So promise.all, when it resolves with a then callback, you'll get an array, and that array contains each slot in the array maps back to the array of requests or promises. And so in that case, when we're awaiting it, we'll get that whole array back. Is that kind of what you were asking?
Yeah, I guess that's correct. I'm looking at this saying, how does promise.all and each one of those is going to be an async function, and so that's one to return back. So those are all going to be resolved.
Not entirely. Maybe after we can get together and make sure I'm understanding you correctly. All right. Thank you, everyone.